All right, a limit. So let's say we have a function that's kind of broken up. Okay, this is called a piecewise function. But let's say the function goes like this. Like this. A piecewise function. Like this. And like that. This one, I'm going to change. Sorry. We're going to go straight this way. All right. So a limit is where a number, the y value a number is approaching. Okay. The limit is the number a y value is approaching at a certain place. So, all right, so we're going to look at the limit as x approaches -7 from the left. Now, there's two negatives involved here. The negative in front of the number is the normal. It's talking about -7. The negative behind the number as an exponent says what direction it's coming from. So that's the direction it's coming from. So as you're coming from the left towards -7. So that means as you're coming like this. What is the y value of this number? Well, the y value along that line never changes. What's the y value here? 5, exactly. So that's a limit of as x approaches -7 from the left. Let's look at the limit as x approaches -7 from the right. Direction it's coming from is that last one. So if we're coming from the right towards -7, we're along this line down here. As we're coming from the right, we're along that line from right there. So as we're going towards that, what's the y value going to be? 1. Okay. Now we're going to look at the limit as x approaches -2 from the left. Well, -2 is right here. If we're coming from the left, it's along this line, which is 1. and the limit as x approaches -2 from the right. -2, an x value of -2 is all along here, right? So if we're coming from the left, we're up here, but if we're coming from the right, we're down here. We're going like this. Going towards -2 from the right, we go down there. What's the y value we're approaching? No. -2, the y value of that point.
I was going up, like on the line.
Yeah, you got to go from the right, you're going towards -2. So you're going down this direction.
How are you supposed to know what line you're on?
You got to look where you end up. You're going to end up at -2. So you're at -2, and if you're coming from the right, you're using this line. If you're coming from the left, the line comes from the left, you're up here, because this is where -2 is at. Okay? My next limit I'm going to look at is at 3. So if we're coming from the left, would we be on the top line or the bottom line? That didn't sound very convincing.
Top.
It's the top one.
Because that one's the top one's at 3.
Yeah. Okay, we're going towards an x value of 3. From the left, we're going up here. And what's the y value of that point? 3. The limit as x approaches 3 from the right. We're going towards 3 from the right. We're going to go on this line because this has a x value of 3. Okay, so you're looking at the x values. These are the x values, these are the y values. So when we went towards -2, this has an x value of -2, it's either here or here, because these are the two values that are at -2. So if we're going towards 3, these are the two values at 3. One's coming from the left, one's coming from the right. Okay? So,
So then the y would be 3. Or no, wait, -1.
-1. Okay?
Infinity.
What's the y value as you keep going up? It's going to keep going up infinitely. What about as x approaches -infinity? What's the y value going to be? Nope.
Wait.
Where does the graph go? Where is the graph going towards -infinity at? It's this line right here. As we're going towards -infinity, as the x value goes towards -infinity, what's the y value of this line? 5. It is, what is the y value when the x value is doing what's underneath? Okay? Okay, I'm going to throw one at you and see how you do. Nope, not 8. I want to do 9. Sorry, I meant 9. What's the limit as x approaches 9 from the left? Where's an x value of 9? Right here. As we're approaching it from the left, where are we going towards? 2. What's the limit as x approaches 9 from the right? Here's 9. As we go here, where are we at? 2. Same place. Okay? So, see how these were separated here so they went towards different things? But if you have a continuous line, both these will go towards the same spot. That spot right there. So we can say the limit as x approaches 9 is 2. Because it approaches from the left and the right and it hits the same number. We can say the limit as x approaches -2, since they're two different numbers, it goes towards different numbers, that limit does not exist. Because if we're coming this way here and this way here, they're different numbers, there's no limit there. But here, if we're coming towards the same number, the limit is that number. The limit as x approaches 3, what would that be? As x approaches 3. Do they have the same number here? No, so that does not exist. And then, yeah, the infinities are infinities. So that's a graphical look at limits, and you'll be tested over graphical limits. Okay? And you'll have just a couple problems today over graphical limits. Okay? But they don't have much to go on. You know, they don't do much with this book and graphical limits like they should. But whatever. I'm not going to worry about that too much. But that'll be part of your homework. The other part of your homework will be figuring out limits when it's limits going towards infinity.
Will you come check 2 answers for me?
No,
Why?
because I can't help you.
You don't have to help. You just have to like look and blink twice if it's wrong.
No, I can't do that.
Will you see if it's written right?
I can see if it's written right.
I'll just explain my process. And if it sounds generally right, you can okay. So for this question, I multiplied that times the other side, and I brought a to the other side, so it was this equals 0.
Yep.
And then I factored it and then got these.
Yep.
And then I put numbers in
Yep.
on the outsides and it could equal this. So I had it like it can be negative infinity to 4 from 2 to chapter 15 all the way because these numbers work and these numbers work.
Okay.
That sounds generally right.
Yep, but you have a mistake on your problem.
Wait. Because I need to go negative 2. So I need to go down.
Yeah, you've got a -2 going on, so I don't think you've checked all the possibilities. Is what I'm saying.
Wait, negative 2 is minimum.
Right. So, well, whatever.
Wait,
So,
what do you mean whatever? Oh my god.
I don't think that one's totally right.
Oh god. I don't know how to do these ones. So this one I tested all the answers and it was supposed to be above greater than 0. So all the places where it ended up negative, I didn't include those, and that's what I. Oh gosh, I'm gonna get these.
I think that's fine. I think you're all right there on that one.
Okay, and then this one, did I do that right? Because I keep getting this one wrong, but I don't know why. So I multiply all these together and get this, and then we'll try that.
Yeah, all your eyes should disappear and then FOIL that out. But there should be, okay, you get a number. And you FOIL that out and add, and so, yeah, hopefully you did your math right.
Oh gosh. If it's like a 90, I'll be fine. Yes. Okay, we're done.
I bet
think it was
it's
that
the one, I bet it's
Because
this one.
I
that
know
you
I
got
don't know
wrong.
how to do it.
But 95 is definitely the keeper. Okay. Infinite limits, algebraic solutions. This is not so bad. This is not so hard.
Told me. It was that problem. I knew it was wrong.
Yeah, because you had to put the -2 in and test that with the rest of them that you were testing. So, all right. So, as you go towards infinity, so let's say the limit as x approaches infinity of 2x minus 4 over 4x minus 2. Okay? What you do is you take the biggest power in both places, or the biggest power of the denominator, and divide. Okay? So you're going to take 2x and you're going to divide by x, because that's the largest power in the denominator. That's the largest variable in the denominator. Minus 4 over x over 4x over x minus 2 over x. Okay? So what I did is I just took x, which was the largest power in the denominator, and divided everything by x. Now you're going to cancel where you can. These x's cancel, these x's cancel. So you get 2 minus 4 over x over 4 minus 2 over x. Then you're going to put infinity in for x. All right, now let's think, because Emmy just said, well, that's just going to be infinity. Not so fast, my friend. Okay. What's 4 divided by 1? What's 4 divided by 2? What's 4 divided by 4? What's 4 divided by 1/2? Or no, not 4 divided by 8. So what's happening to these numbers? They're getting smaller and smaller. They're getting close to 0. So as the denominator gets bigger, these numbers are getting closer to 0. So what's 4 over infinity? 0. So it's 2 minus 0 over 4 minus 0, which is 1/2. So if you would graph this function as you go towards the right, it would go closer and closer to the number 1/2. So if I graph that, I'm going to flip my computer this way. So my graphing calculator flips big. And I go y equals, clear, turn off my plots. Go up, hit enter, and go down back down. Okay? So my numerator was 2x minus 4. And my denominator was 4x minus 2. If I go zoom 6, it looks like that. Now, if I trace, as I go to the right, and I keep going to the right, and I keep going to the right, it keeps getting bigger and bigger, right? But it only gets bigger to a certain extent. And if I change my window to like 10,000 for my X max, and I trace, see how I'm really close to 0.5? And the further I go to the right, the bigger I get. And I get closer and closer and closer to 1/2. Am I going to ever get to 1/2? The answer is the calculator will say, yep, I get to 1/2. But I'll never get to 1/2, but I'll be so infinitesimally close to 1/2 that we just say we're at 1/2. Okay? Let's do another one. As x approaches infinity of 5x cubed minus 4x squared plus 3x minus 2 over 2x cubed minus 3x squared plus 4. I'm sorry. So what you do is, what's the highest power that appears in the denominator? X cubed. So you're taking everything divided by x cubed.
Why so many numbers?
Because I'm a jerk.
Yeah, I know.
So if we simplify them, it's 5 minus 4 over x plus 3 over x squared minus 2 over x cubed over 2 minus 3 over x plus 4 over x cubed. What's 4 over infinity?
0.
0. What's 3 over infinity squared?
0.
What's 2 over infinity cubed?
0.
This one will approach 5/2. Now, for the first two problems, well, all your problems today will have the powers be the same. So I think I'm not going to mess with your heads too much. Okay? Let's do another one.
I'm up.
Let's find this limit. What do you think we have to do in the numerator? I think we have to FOIL. Outers is 4x, inners is negative 2x, which is plus 2x. Last times last is negative 8. What do we divide by?
X squared.
X squared.
So cancel out 2 over x minus 8 over x squared. And then at the bottom it's negative 1 over x squared.
Can you do that?
Yeah.
All right.
I gotta get too much brain power for that. 723. I don't even have. understand what this question is asking. Oh no. Oh my god. Ugh. Which one? Like this one or the class exercise?
The class exercises. This is the class exercises.
Okay.
And this is the written exercises.